So let's have a visual of how we make a solution by dilution. And here's our equation, M1V1 equals M2V2. And we're looking at how to make 5 liters of a 1.5 molar KCl solution from 12 molar stock solution. So this is what we just calculated in our previous voice lecture, and we figured out that V1 was 0.625 liters or 625 milliliters. So what we do is we measure out 625 liters of our 12 molar. Our stock solution is our concentrated solution. So we add this to our volumetric flask. And remember, our volumetric flask is a flask that has one line on it that tells us that for a specific volume. So we're at our 625 liters or 625 milliliters of our concentrated solution, and then we add enough water to make 5 liters using this volumetric flask. So then we've taken a concentrated solution, we've added water to it, so our new molarity, 1.5, is lower than our original molarity of 12, and our new volume, which is 5 liters, is much less than the volume, 625 milliliters, of our stock solution. So let's look at some practice. Let's look at finding the concentration made by diluting 125 mils of a 0.8 molar solution of HCl to 500 mils, and then also the concentration of solution made by adding 200 mils of water to 800 mils of 400 ppm. So go ahead and pause this lecture and then see how far you can get, and then I'll do these problems and we'll see if you got the right answer. So the first thing that I do is I write out the equation that I know I'm going to need. Since this is a dilution problem, this is my equation. And since this equation has 4 variables, I write out the term for each of the 4 variables, and then I fill in what I can. I notice that my initial concentration, according to my problem, is 0.8 molars, and I have 125 mils of it. So I have 125 mils of 0.8 molar, and I'm going to dilute it to 500 mils. So what is my new molarity going to be? So if I look back at my notes, I'll see that this is the equation that I have to use to solve for my second molarity. And I'm just going to plug in 0.8 molar times 125 milliliters divided by 500 milliliters. So my milliliters cancel out, and my new concentration is 0.2 molar. And this makes sense because it's smaller than my original molarity. Let's look at the second problem. Okay, here my concentration is not molarity, it's parts per million. And I'm told that I have 800 mils of 400 part per million. So that's my concentrated solution. My new molarity is what I'm solving for, and my new volume is 1,000 milliliters because it tells me my new volume I get by adding 200 mils of water to my original 800 mils of solution. So again, I'm just going to use my same equation. M2 is M1 times V1 over M2, and I'm just going to plug in my original molarity, 400 parts per million. Oops, forgot my P there. Parts per million. My original volume, 800 mils. And I divide, whoops, I have B. I divide by my second volume, which is 1,000 milliliters. My milliliter units cancel out. And my new concentration is 320 parts per million. And that makes sense because this concentration is lower than my original concentration.